smoke from Canada that's pretty pervasive across the upper Midwest. We'll chat about that coming up, but let's get into the slides. So we always talk about general information. This is a collaborative effort amongst state and federal agencies. We have multiple partners across the region that really help us consolidate information and then get that information out to our stakeholders, media, general partners. So it's a great collaboration. I couldn't do my job without Doug and Dennis and all of our other colleagues. So I just thank them for that. Our next webinar will be on June 15th, and our presenter will be my friend, Dr. Aaron Wilson, state climatologist of Ohio at the Ohio State University. Finally, you can find past presentations and also links to future webinars in the links below. Okay, so we'll get into our presentation. What we'll look at: recent conditions, temperature and precipitation ranks for April and then year to date. Then we'll look at 30-day temperature and precipitation. Departures give us an idea of the behavior that we've seen over the last 30 days, and then the impacts on drought, especially in the western part of the central region. Then we'll look at planting and growing progress, impacts on agriculture and other sectors, and notable events over the last 30 days. And then finally, outlooks. Doug mentioned El Nino possibilities. We're currently sitting in ENSO neutral conditions with a high probability of a shift to El Nino in the next several weeks. Short-term outlooks, and then looking at June, July, and August as a meteorological summer. On the right-hand side here is that smoke plume over the Great Lakes from a brief rain with NOAA. So it just shows you how wide that smoke trail started, and it's really spread out over the upper Midwest. Okay, recent conditions, as I mentioned, April, and then year to date give us an idea of where we're stacking up in terms of rankings going back to 1895. Long-term precipitation departures going back 3 years with the current drought, and also soil moisture, stream flow, and other moisture indices that give us an idea of drought or wetness. So if we look at April temperature ranks, these are statewide average temperatures. So the warmer the color or the redder the color, the warmer the month for that state. The bluer the color, the colder the month, and then that white, generally near normal conditions. So if we look at our central region, we generally have colder conditions across the northern tier. You look at North Dakota, the 10th coldest April on record going back to 1895. And then South Dakota and Minnesota, some particularly cool average temperatures as well. And then you get into Iowa, Nebraska, Wisconsin, we start to shift towards near normal. And then Eastern Corn Belt, we get into those warmer temperatures. So overall, a mixed bag across the region from warm to cold. Now, if we look at daily temperature records or temperature records that are set on a given date, not a monthly record, we see a lot of daily high temperature records broken during the month of April. We had several days in which we saw temperatures 15, 20, 25 degrees above average during the daytime, but also record daily high minimum temperatures, so overnight lows that were warmer than average. So you can see across the region lots of maximum high temperature daily records broken, and then interspersed those high minimum records, and then those the black square there, that's both. So a lot across Wisconsin, Minnesota, and then getting into Michigan and Indiana. On the right-hand side, again, another picture here of daily low temperatures. So we had a lot of swings over the month of high temperatures and then low temperatures. We had a stretch in which we were, as I mentioned, 15 to 25 degrees above average, and then we see a 50 to 60 degree temperature swing over the next few days as cold fronts move through the state or through the region. So you can see we have both flavors of those records. Now, if we look at precipitation, again, to situate you here, this is April. The greener the greens, the wetter the month for the state. The browner the browns, the drier the month for the state. You can see wetter conditions across the upper part of the region, Minnesota into Michigan. But then we have drier conditions across the rest of the region, stretching from Indiana all the way up through the Dakotas. you look particularly at very dry conditions in Nebraska and Missouri, top 5. And that's where we started to see drought conditions really start to expand along the Missouri River in Missouri. So definitely drier conditions for April. Now, if we go to year to date, so the January through April temperature recap, and again, these are the same plots that you saw for April, but for January through April. The warmer temperatures across the eastern Corn Belt, similar temperature pattern that we saw through much of winter, warmer east, colder west, and then we have an interface of near average conditions across Minnesota, the Dakotas, and then into Nebraska. Top 10 warmest year-to-date start for Missouri, and then getting into Michigan and Ohio. So you look at the United States, it's a patriotic pattern right here with red, white, and blue, with red east, blue west, and then some near normal in between. Now, if you look at precipitation, wetter across the eastern Corn Belt, near normal west. We start to swing up into Montana, North Dakota, drier conditions from January through April. Very wet in the upper Midwest. You look at Michigan and Wisconsin, wettest year to day start for Wisconsin, top 5 for Michigan. So very wet conditions, a persistent storm track across the upper Midwest, and hence you get these very wet conditions. Now, if we look at county ranks, this gives us an idea on the county scale of where we're seeing particularly wet or particularly dry patterns. Definitely, as I mentioned, across Wisconsin, Michigan, the upper peninsula, and into eastern Minnesota. And then you start to see dry pockets here and there across Nebraska and Kansas, up into North Dakota, northern Minnesota, and then over into Montana. So wet pockets, dry pockets, but particularly wet pockets across the upper Midwest. And we zoom in on Wisconsin with the wettest year-to-date start of January through April. I went into Climate at a Glance and looked at the rankings and put the rankings in here, and you can see several counties wettest start on record, second, third, top 10. All the top 10s are marked there. So particularly wet conditions for our friends in Wisconsin. And it's reflected in soil moisture profiles, but also a lack of drought. Now, if we look at the last 30 days, this is the temperature departure, and we see a pretty general pattern here where that line is anywhere east of that line. Temperatures generally up to 2 degrees below average, but you get into the eastern Corn Belt, Indiana, Ohio, parts of Michigan, you're starting to see temperatures in the 2 to 4 degree below average range, and then pockets up to 6 degrees below average. You go west of that diagonal line into western Iowa, Nebraska, Kansas, you're seeing temperatures pockets of 4 degrees, getting up into Montana, even warmer temperatures. But overall, not exceedingly above or below average, but for 30 days, getting 4 to 6 degrees above or below average is noteworthy. Now, if we look at percent of normal precipitation, and again, this is derived from the 30-year climatology, so the last full 3 decades, 1991 to 2020, we subtract that from the behavior that we're seeing on the ground. This gives us the percent of normal precipitation. So wherever you see those warmer pockets, especially in Missouri, anywhere from 50 down to 25% of normal with localized drier conditions. And that's where we really started to see drought conditions intensify and expand just over the last several weeks. Then you get into pockets of northern Iowa, southern Minnesota, and then especially over in the Dakotas, swinging down into Nebraska and western Kansas. Totals or departures positive 150 to 300% above normal, where that rainfall is desperately needed in the D3 and D4 regions in these states. So it's been nice to see these rainfalls occurring even in northwestern Iowa, where we have that D3 and D4 corridor. D4 was extinguished over this week. So we are seeing wetter conditions, but drier over the last 30 days across the eastern extent of our region. If we look at the last 3 years. So looking at 3 years of La Nina, looking at 3 years of drought conditions across much of the western portion of our region. You see that bullseye right in the middle, in the corner of South Dakota, Iowa, and Nebraska. 50 to 75% of normal precipitation over the last 3 years. You have pockets around Sioux City, 15 to 25 inches below average over that time period. So particularly dry patterns here, longer term precipitation deficits, and that's a reflection of those drought conditions that we see. We shift towards the eastern part of the Corn Belt, 90 to 100% of normal, pockets of 80 to 90, but the eastern part of the Corn Belt has fared a lot better over the long term than we have in Iowa and further west. Part of that is a signal, elevated probabilities of wetter conditions during that La Nina phase for the Ohio Valley and getting into the Great Lakes, and we do see some semblance of that here. Now, if we look at soil moisture, this is the NASA Sport 0 to 200 centimeter remote sense soil moisture percentile. So this goes down to about 80 inches. And percentile meaning, think of a sponge, the 98th percentile where you see those darker blues, that sponge is saturated. Really no more room for infiltration, very wet soils for this time of year. And then you swing back towards the warmer side in Missouri, eastern Kansas, getting up into Nebraska, you see those tans and reds, a very big improvement over conditions that we were seeing last year. We had percentiles that were much drier. Now some of that has to do with the NLDAS to temperature bias, but we won't get into that today. But we've seen improvement, and it's been beneficial improvements across much of the region. Very wet conditions, as you can see with those blue colors, 98th, 95th percentile across the northern tier, but overall drier soils, but we're rebounding in terms of infiltration of moisture. Now, if we look at another modeled product from the Climate Prediction Center, telling us the same story, top left-hand corner here, we're seeing, again, percentiles across eastern Minnesota into Wisconsin and Michigan in the 99th percentile. Very wet conditions for this time of year. And then we swing down into, again, Nebraska and Kansas. That's where we're seeing particularly drier conditions for this time of year. And then you get that bullseye in central Missouri, which is situated right around the driest conditions that we see on the drought monitor depiction that was released today. You look in the bottom right-hand side here, this is the delta or the change map since the beginning of the month. Wherever you see those greens on there, that's where we've seen an increase in soil moisture. On the flip side, where we see those tan to brown colors, that's where we've seen soil moisture departures, so extraction of soil moisture or deficits in precipitation. Lots of tight gradients there, especially along the Missouri, Iowa, Minnesota border, where we've had some heavier rainfall events, anywhere from 6 to 8 inches over several hours. Several waves of thunderstorms as well. So we've seen some improvement in the western part of the region as well. But overall, I'm more optimistic as we see improvement in the model than the remote sense products. Now, if we look at USDA NASS, the North American Statistical Service, we have two versions of this map, topsoil and subsoil moisture. The next two slides will be the same, percent short to very short, so giving us an idea of how short topsoil moisture is for the reporting period. And then on the right-hand side, that's percent adequate. So we're thinking surplus, not surplus, but adequate amounts of soil moisture versus very short. Well, if you look at percent short to very short in the eastern part of the Corn Belt, where you see that number in the bracket, that's the change from last week. So we've seen some moisture extraction and precipitation deficits in the eastern part of the Corn Belt. So we've seen a slight decrease in the amount of topsoil moisture. Also, atmospheric demand is starting to ramp up as we get into the growing season and the warmer part of the growing season. You look on the right-hand side here, Again, the bracket number is the change from last week. So we see lots of pluses across the region. We see a negative 6 in Minnesota, but overall where you see these pluses, that's where we've seen an increase in topsoil moisture, and that's a reflection of a more active storm track that we've seen just over the last 7 to 14 days. Now, if we look at the subsoil moisture profiles, again, we're seeing a similar behavior. You look across the darker browns that we see on the left-hand side here, that's where we're seeing very dry conditions. But below that, again, is the change from the prior week, and we have seen some improvement given the rainfall events and the more active storm track that we've seen across the western part of the region. You look at percent adequate on the right-hand side here. The greener the green, obviously, the wetter the soil profiles. So we have seen also improvement or additional infiltration of subsoil moisture, and we've seen improvement. Now, Missouri sticks out there, been in a drier pattern, and that's also a reflection of the expanding drought conditions that we see there. Okay, so we take all these soil moisture and the precipitation deficits, the additional other moisture fields that go into the U.S. Drought Monitor depiction each week. This is the current map that was released this morning, and again, it's backdated to 7 a.m. on Tuesday. So any precipitation that falls after 7 a.m. on Tuesday, Central Daylight Time, is not reflected in the map this week. It'll be reflected in next week's map. Overall, what you can see, the drier conditions in Nebraska getting down into Kansas, and then basically drought-free and abnormally dry conditions, which is not drought, but more of a signal of 30 to 60-day dryness, absent from the western or the eastern extent of our region. That, again, those drought regions that we see are basically in Nebraska and into Kansas, the most pervasive of them, and then getting into shorter-term D1, D2, and then a little pocket of D3 in central Missouri, and then the existing D2, D3 region in western Iowa, where we have seen improvement as well. Now, if we were to look at the map last year at this time, you can see much of the drought region still remains in the western part of the region, with basically Iowa east, not really any drought or abnormal dryness. Now, as we were going through the iterative process last year, we started to see drought intensify across Missouri, parts of the upper Midwest, and then into Iowa. So we were starting to see a lull in drought expansion, and then we start to ramp it up as we get into the growing season, June, July, August. Now, if we look at a 4-week change map, so this is a difference between the map released this morning and a month ago. And to situate you here, the greener the greens, the more class of improvement that we see, 1, 2, 3 class. So you can imagine a D2 category, a 2-class improvement would bring you to D0. So that's what a class improvement is. On the flip side, you look at Missouri, where we've seen anywhere from 1 to 3 class degradations in west central into central Missouri, as a reflection of a shorter term drought out a few months, but those precipitation deficits are starting to stack up. Overall, improvement in general across the region, and then some pockets of degradation in Nebraska, Kansas, and then getting up into Montana. Okay, so now we'll look at growing season progress, and this picture is from Hans Schmidt in Indiana, and we're seeing a red tractor pulling a green planter. So we can get along. He had a great quote in an email that he sent me and gave me a chuckle. So let's look at our corn progress across the region. Left-hand side is percent planted, right-hand side is percent emerged. Wherever you see those warmer colors, that's where we're behind the 5-year average. And the bracket number below the top number, again, is the change from the 5-year average. So whether we're ahead or behind, if we're ahead, we see that plus. If we're behind, we see that minus. You look at the central part of the region, Missouri, Illinois, and Iowa, we're ahead by anywhere from 14 to 21 days, so 2 to 3 weeks ahead of being planted. Now, we had some cooler and wetter periods in April that slowed down planting progress, but we did also have periods in which planters were rolling at a pretty rapid rate getting planted. Our problem child regions are in Wisconsin, Michigan and over into Ohio, and then North Dakota. But overall, if you look at the states in the region, we have seen a pretty productive planting progress so far. On the right-hand side, if we look at percent emerged, Missouri is a green state, a bullseye of plus 32% or plus 32 from the 5-year average. So very rapid emergence progress in Missouri, and then we see that across the southern tier of our states, and then slightly behind as we get into the northern tier. Same plots, but for soybeans. So we have a percent planted on the left, a percent emerged on the right. Seeing similar behavior in terms of in our region where we're seeing a rapidity of being planted, 21 days to 38 days ahead of the 5-year average, getting in the central part of the region. And then you look at those northern tier of states, that's where we see a slight departure from the 5-year average. And again, this is related to more active storm track and wetter conditions in the planting parts of the state. A percent emerged on the right, pretty good progress across from the eastern part of the region, swinging over into Nebraska and Kansas, and then we've got those very green colors in Missouri and Illinois. And then basically status quo or near, not a lot planted, or not a lot emerged in our northern states, but overall, it's looking pretty good. Now, if we look at spring wheat on the left-hand side here, percent planted, and then sugar beet progress, percent planted on the middle plot, and then oats on the right. Wheat lagging behind in Minnesota and North Dakota, and then slightly ahead in South Dakota. Still some wiggle room there in Montana. Sugar beet progress ahead in Michigan and Minnesota, slightly behind in North Dakota. And then we look at oats, 99% planted in Iowa, 95 in Nebraska, slightly ahead of schedule. And then we get into our northern states, slightly behind schedule, anywhere from 9 to 29 days up in North Dakota. Swing over into Ohio, about a week ahead of schedule.
And some of that,
okay, so now we're shifting.
Yeah, and some of that reasoning is that a lot of those places were under snow for so long and has a lot of deep snow. So
Yes.
Generally that's the case, and it relates to some of the questions that are being asked. So go ahead. Sorry.
Deep snow, Mississippi River flooding with rapid melt. So that's, yes, progress shows behind. But we'll switch gears into snow, fire, rivers, and lakes. So all the different variables across the region. The first thing we'll look at is the snow water equivalent in the basins across the western extent of the region. So overall, the snow water equivalent, or the liquid equivalent in the snowpack, if it were all melted, ranges from 80 to over 100% across much of that polygon that I have there. So one reminder and one caveat here is the snow water equivalent percentages can be misleading this time of year, given the time of year and the melting of the snowpack at lower elevations versus higher elevations. So higher elevations are holding on to snowpack, while below about 8,500 feet, that snowpack has melted. So that snowpack has been ingested into the stream systems and reservoirs. So over the next several weeks, we're watching temperature outlooks for the potential of high elevation melting and how rapidly that high elevation melting will go. If we look at the mountain snowpack water content in the Missouri River Basin, and we have two plots here, totals above Fort Peck, and then from Fort Peck to Garrison. These are the plains snowpack has generally melted into the basins. The snow water equivalent is 11.2 inches above Fort Peck, and 60% of the annual peak remains. And as a reminder, normal peak is right in the middle of April 17th. Snow water equivalent from Fort Peck to Garrison is 9.2 inches, and that's 58% of the annual peak remaining. Mountain snow water equivalent is at 117% of normal above Fort Peck, and then 109% of normal from Fort Peck to Garrison. So you look at the plots, wherever you see that blue, that is the 2022 to 2023 average versus the long-term average, 1991 to 2020, in that red line. So if you're above that line, you're above average. If you're at that line, you're right near the average. If you're below, slightly below average. Now, if we look at the Missouri River system storage in general, and this is a update as of May 16th, during the month of April, the reservoir system gained approximately 300 million acre feet of storage. System storage, as we speak, is at 50.6 million acre feet, still below the 1969 to 2022 average. So if you look at the plot there, that the dashed line is where we were in 2022. That red line is 2023. And the average, if you move up a little bit in that plot, are those stepped blue lines as we go up through June, July, and August. The Gavin's Point release is currently 20,000 cubic feet per second and will be adjusted. The Army Corps has signaled that these will be adjusted as needed for downstream navigation targets. Okay, so another moisture variable that we look at is the 28-day stream flow, average stream flow at our USGS, United States Geological Survey stream gauges across the region. Again, this is a percentile basis, so wherever you see green, that's where we're in the normal part of the distribution, as opposed to those darker blues where we're across the Dakotas into Minnesota and Wisconsin, above normal to much above normal over this region, given the snowpack that had melted through April, but also a more active storm track with more precipitation. Then you get into the southern part of the region, the warmer colors really start to stand out where drought conditions continue to exist, especially that swath across central Missouri and then getting into Kansas in southern Nebraska. So we see much below to low stream flows in these drought regions. And again, that's a reflection of precipitation deficits over several weeks. Now, if we look at the Eastern Corn Belt, generally near normal, getting down into Kentucky, we start to see that below to much below in certain basins across the region. Now we're switching to significant wildland fire potential outlook. And we look at May 2023, as we currently are situated, we really don't see any above normal potential across the region. In fact, we see below normal potential across North Dakota and getting into Montana. Now we are seeing an import of wildfire smoke, a vast amount of wildfire smoke from Canada that's propagating south into the United States, and I'll show you maps of that later. But as of right now for May, not really seeing any above normal potential. Now as we move into June, we do start to see with drier fuels the potential for above normal fire potential across Minnesota, Wisconsin, into the upper peninsula of Michigan, and even over into Michigan proper. So we have seen a shift in terms of the potential in June. And then we look at July, again, that potential basically is normal. So what we would expect for this time of year. Now, looking hydrologically at the Great Lakes, looking at temperatures in the lakes versus where the sea ice is, not sea ice. I did sea ice modeling as a grad student, but looking at lake ice, only a little bit left up in Lake Superior, just right in the very tip top there. So overall, lake ice is gone, and we look at water temperatures for the 5 Great Lakes, generally around average for this time of year. As of May 14th, 0.2% of the lake is covered in ice, and that's contained within that little circle up in the top of the picture. Great Lake water levels. Water levels on the lakes are continuing their annual spring rise due to wetter conditions as we start to see more precipitation, but also that snow melt that the lakes will ingest along with our stream systems. And according to the Army Corps of Engineers, Detroit, Michigan, Huron, Erie, and St. Clair are close to their May 2022 levels, and then Lake Superior and Lake Ontario are above their May 2022 levels. So overall, we look at the lakes, all lakes are above their long-term average for May, but definitely below the very high levels that we saw back 2018, 2019. All right, so now we'll shift to notable events and impacts on various sectors across the region. This is a picture from Aaron Wilson in Ohio, looking towards the smoke coming from Canada, but also buffeted by an incoming cold front. So a very cool picture to look at on the horizon. All right, so I pulled different highlights from newspapers across the region. We've had all varieties of extremes across the region. We had Mississippi River flooding along Iowa, Illinois, Minnesota, and Wisconsin. We had a winery in Wisconsin, in fact, that lost almost all of its red grape crop due to these fluctuating temperatures that we saw throughout through April. And I have a figure that state climatologist Steve Avris sent me from Wisconsin. Out of control wildfires in Western Canada, no wildfires here, but we're seeing that inundation of smoke across the region. And then, of course, drought remains across the breadbasket, across Nebraska, Kansas, Western Iowa. So all the negative impacts from extremes, both dry and wet extremes. We drill down on specific states. We look at Kansas. Some locations in the northwest part of the state were on day 288. This was last week, without more than a half an inch of precipitation. That's where we see the most pervasive drought conditions in Kansas. Pastures were in terrible shape, producers low on feed. Now, last week, from this report from Gannon Rush, a complete 180 with significant precipitation and flooding over the drought region. So again, the pendulum swings back and forth. We get into dries and then we get into wets. This is a quote: "It was a blessing and a curse because it sounds like some of the fields west of us were destroyed by both hail and wind." So we have seen a lot of severe weather across the region from Nebraska all the way through the eastern part of the region. Lots of large hail, tennis ball, golf ball size hail from Iowa into Illinois, but we have seen damage. Now, the silver lining there is when you do see more severe weather, you see more thunderstorms, you get more precipitation, and hence you see drought conditions start to tail off and you start to see improvement. Another headline was Plains farmers brace for historically poor winter wheat harvest. This gets into drier falls, not efficient germination, and then snowpack and ice crystal formation through the winter time, damaging the plants. So this was the plot that I mentioned from Stephen in Wisconsin, showing the bimodal behavior of temperatures across Wisconsin. First half of the month, almost 8 degrees above average. Second half of the month, 8 degrees below average. So climatologically, near average for April. But this gives you an idea of those temperature swings and the frost and freeze events that were damaging to that the grapes up in that specific winery. Also in Monroe County on April 12th, a smaller scale wildfire. And then on the 16th to 17th, a pretty epic snowstorm near La Crosse with totals 8 to 12, locally up to 18 and 24 inches. So we're in a very transitory part of the year where we see all modes of precipitation, all modes of severe weather, and we had lots to talk about. We have lots to talk about. Now, of course, I mentioned Mississippi River flooding. You know, speaking with my colleagues across the region, especially along the Mississippi River, for the moderate to major flooding that we saw along the river gauges for me from Dubuque down to Keokuk, not approaching record levels, but pretty good reaction, pretty good lack of impacts from these rising river levels from the rapid snowpack melt across Wisconsin and Minnesota and even into Michigan. So yes, we had moderate to major flooding across much of the the upper basin down towards St. Louis, but not very impactful, which was kind of, scratch your head given how much river infiltration that we had from melting snowpack. But overall, I think we have crested along the Mississippi, and those levels are going down, as you can see on the plot on the right there. Now we can look at various state impacts across the region. Again, I didn't have 3 hours, so I couldn't list all of them. But row crop planting generally ahead of the 5-year average, with some states and some parts of states lagging behind. A dry fall and an active winter has impacted winter wheat, especially in Kansas and South Dakota. Wisconsin, as I mentioned, wettest year-to-date start on record. Looking at Colorado, six consecutive months of statewide below normal temperatures. And then we shift back into Wisconsin, unseasonably wet conditions for 6 months. So to see 6-month stretches of above or below normal behavior is anomalous. We don't see that often. Another thing of note in Colorado was an observed 98-mile-per-hour thunderstorm wind gust on May 5th. You don't see wind gusts that strong, especially in Colorado, but they had one at 98 miles per hour. Trent Ford, state climatologist of Illinois, told me freeze damage at a peach orchard could produce losses at 60 to 70% of the potential yield, which is staggering in terms of the economic damage that can do. And then talking back to Mississippi River flooding, that has impacts across the region. With rising levels on the Mississippi River, barge traffic was halted. With halted barge traffic, we don't get those inputs that we need across the region, especially fertilizer. Laura Edwards in South Dakota mentioned a 4-mile long line of trucks and vehicles to find fertilizer because it was so scarce given the barge traffic halting. And then significant hail damage, sporadic but significant, to high tunnels and alfalfa stands across southern Iowa and into Illinois after multiple waves of severe thunderstorms. I started receiving lots of media inquiry about, are we seeing larger hailstones in the springtime than we have historically? Hail climatology is difficult to get into, but we've definitely seen golf ball to tennis ball size hail on several occasions across the state. Now, luckily, row crop emergence was minor, so we really didn't see widespread damage to corn and beans, but we did see impacts to specialty crops. And then, of course, the May 1st I-55 dust storm in Illinois. Cultivated soils with a northwesterly wind in the range of 45 to 55 miles per hour that was generated by a cutoff low pressure over the Great Lakes. Several things came into play. Several factors had to come together to produce this dust storm, but it produced multiple crashes across I-55 in 2 counties in central Illinois, and visibilities were reduced to 0. According to the Illinois State Police, 72 vehicles were impacted between just 2 miles of mile markers, 76 and 78. And unfortunately, there were 8 fatalities. An additional fatality was reported yesterday. 37 people were injured. So again, the topsoil was in a primed position to be lofted by these very fast winds that were nearly perpendicular to the highway. So you had, if you look at the 3 images I have here, these are captures from satellite images, and you can see the plume towards Champaign really start to pick up and move south, and that's where you really started to see visibilities near 0, and hence the pretty catastrophic crash in that bottom right-hand corner. Okay, so if we look at overall severe weather season so far, and I'm getting sparse on time, so I'm going to move it around here. About 200 reports more than last April. So we have seen more severe weather across the region. And this goes hand in hand with the improvement in drought conditions that we've seen across much of the region. More thunderstorms, more rainfall, more precipitation to extinguish drought conditions, but also pretty substantial rounds of severe weather 4th, 5th, the 15th, and the 19th through the 20th across several states. And here's a screen capture from the Quad Cities National Weather Service on the size of hail that we saw in eastern Iowa and western Illinois. And again, this is the smoke plume from GOES East coming out of Canada. The smoke plume is that hazy cloud right here. Very pervasive. Beautiful sunrises and sunsets. We're not seeing a lot of air quality issues yesterday, but we have started to see that smoke mix down into the lower atmosphere. Finally, we'll look at climate outlooks, ENSO neutral, and the possibilities of El Nino, and then our short-term outlooks and forecasts. So we're currently in an El Nino watch. We're in ENSO neutral conditions, so in between La Niña and El Nino, so near normal sea surface temperatures in the Pacific. And again, this is after 3 consecutive years of La Niña. Those sea surface temperature anomalies are trending warmer through the ocean, though ocean and atmospheric coupling has not occurred. So for El Nino to actually come to fruition, the atmosphere has to respond to those warmer sea surface temperature anomalies in the eastern Pacific, and we haven't seen that yet. If we look at the modeling, the transition to El Nino is expected in late spring into early summer, and we have higher probabilities of that pushing into a northern hemisphere winter. Now, if we look at the going back to September of 2020, we do see that that purple line is below the La Niña threshold and tracking along until we start to get into 2023. We see that line go into the ENSO neutral period, the ½ degree to -½ degree centigrade line. If we look at the bottom right-hand side there, though, in the April, May, June timeframe, we start to see the modeling go above the El Nino threshold, so those warmer sea surface temperature anomalies. And then as we get into late summer and late spring into summer, we start to see the model average converge around 68% probability of a El Nino occurring. And again, the atmosphere has to couple to the ocean for that to come into fruition. Now, the probabilistic models are showing us the percent chances on the vertical axis here, the seasonal time slices along the horizontal axis. And wherever you see the gray bar, that's the neutral condition. Wherever you see the red bar, that's the El Nino phase. So the higher those red bars, the more likely that El Nino occurs and stays around. So once we get out of the May, June, July timeframe, we see those probabilities in the 80 to 90% range. So high probabilities of a shift to El Nino conditions. Now, what does this mean? So there's a lot of wiggle room when we talk about the possibility of El Nino impacting summertime conditions. Now, if we look at the correlation between El Nino and summer season precipitation, it's not particularly strong, and that's a function of mesoscale or smaller scale weather patterns that produce our precipitation, so thunderstorm-driven rainfalls, versus in the wintertime, we have more robust guidance if we are in an El Nino winter, given the synoptic scale or the larger scale weather patterns that set up across the United States. But if we look at the June-July timeframe on the left, temperature, right, precipitation, the increased risk of warm or cold extremes on the left or wet or dry extremes on the right. Typically, we see in those El Nino years getting into late spring and then summer, somewhat cooler conditions over much of the region, but also not as dry as that La Niña phase. Now, the caveat here, these plots are not forecasts, but rather an average of the past behavior as a percent and the percent of increase in the risk of those wetter extremes, especially where you see those darker green climate divisions. So overall, again, given the smaller scale features that drive precipitation across the region as we get into summer, the El Nino phase will have an impact, but there is some variability when we do look at analog years going back to 1950. All right, looking at the outlooks and the forecast finally, the 7-day precipitation forecast has generally dry conditions. If you look at Iowa, 1/10 of an inch or less, wetter conditions north and south, getting into Kansas and Nebraska, and then slightly wetter conditions if we go over to Indiana and Ohio. So more of a quiet storm track as opposed to where we've been over the last few weeks. If we look at the short-term outlooks, 8 to 14 days, again, these are probabilistic, temperature on the left, precipitation on the right, valid from May 25th through the 31st. The warmer the color on the left, the higher the probability of being above average temperature-wise. On the right-hand side here, Eastern Corn Belt, slightly elevated chance of drier than normal conditions, transitioning to near normal, and then slightly wetter as we get into South Dakota, Minnesota, Nebraska, and Kansas. If we look at the possibility of heavy precipitation, we see a slight risk, southern Nebraska getting into Kansas. And this is the May 24th through 26th time frame. So a potential for heavier precipitation, which would be, we don't want heavy rainfall events, but this would be great for those drier conditions that we see. If we look at the initial June outlooks that were released this morning, again, an elevated bullseye for warmer temperatures in the western part of the region, and then buffeting that to the west of that pattern is above average for a precipitation, namely in South Dakota down through Nebraska and Kansas.
Let's caveat
Finally,
Justin, let's caveat that just a little bit by saying these probabilities are very low in terms of tilting towards above in both those regions that Justin is talking about. Those are not strong. Those aren't strong opinions. I'll just leave it at that.
and again, Doug makes a great point. This is the initial June outlook, so we'll have, as the models update and ingest better information or better observations, we'll have a final outlook issued at the end of May. So hopefully we'll have more guidance in terms of final June behavior. If we look at the June, July, August outlook, again, this was issued this morning. We are seeing across much of the region the equal chance, so equal chances of above, below, or near average behavior. And then jutting over into June, July, and August, that elevated probability of wetter conditions across the Ohio Valley and getting up into the Great Lakes, and equal chances across the rest of the region. This is a more La Niña-ish looking signal to me right now. So as we start to transition, and if we transition into El Nino conditions, we will see updates in further iterations of these seasonal outlooks as we get in late summer into fall. Finally, seasonal drought outlook with that wetter possibility given the potential for El Nino. We are seeing the possibility of improvement and removal of drought across the entire region. In fact, only a little pocket of drought persisting in Montana. Now you have that opaque whitish color. You have drought remaining, but you have category improvement in those regions. So namely central Missouri, and then especially in Nebraska and Kansas. So outlook summary, short-term outlooks are showing higher probabilities of warmer temperatures across most of CONUS, the continental United States, and wetter to near normal precipitation potential. Seasonal temperature outlooks are not clear-cut right now, that equal chance across western portions of the region with the potential for warmer and wetter conditions east. As I mentioned, drought conditions region-wide look to improve. And so neutral conditions are currently with us, and with a high probability of a transition to El Nino in late spring and early summer. And when we look at those analog years, or years in which we have summertime El Nino conditions, generally cooler across much of the region and not as dry as that La Nina signal. Now again, mesoscale or thunderstorm-driven weather patterns are hard to pin down given how they set up in the modeling compared to those larger scale synoptic low pressure systems that bring us widespread precipitation during the cold season. So that's where we see some variability in the behavior of El Nino. And I mentioned drought improvement. Okay, so further information, our past recorded presentations are on these links at MRCC. All the other Climate Prediction Center, drought outlooks, National Drought Mitigation Center, state climatologist, all those links there. Our contact information, should you have any questions for us after this webinar. Finally, we'll take questions.
Okay, thanks, Justin. Just some Just some other thoughts. It's as we've said on this for the last 12 years when in doing these presentations. When we get to the summertime, when we start looking at longer seasonal and even monthly forecasts, it gets tough, and the confidence level of the forecast is down because the models don't behave as well. I'll just leave it at that. And we're in a transition period, as Justin said, from relatively neutral now to hopefully, meaning that's the forecast, and hopefully we can hit our forecast in terms of El Nino. There will be some repercussions for El Nino, but we'll talk about those as the seasons or as the months go along. It's going to be tough this summer to say, oh, that's because of El Nino. Sometimes people are saying that already, and it's not true because, as Justin also said, the atmosphere is not necessarily behaving in sequence with the Pacific at this time. That probably will evolve by late summer. We'll see how it goes. And we'll also see coming up in the next week or two the hurricane forecast for the Atlantic and the Pacific. And it'll be interesting to see with El Nino emerging. Usually that means less tropical activity. We'll see what they say this year. The questions. So let me go to some of these about smoke, because I know people are kind of worried about smoke, and I see a lot of smoking questions, a lot of smoking guns here. So this one's for you, Justin. What is the impact of corn and soybeans? What is the impact of corn and soybeans posed by the fires and the smoke, really?
Yeah, so the Iowa Environmental Mesonet has a great plot on their front page that looks at wildfire smoke impacts on incoming solar radiation. Now, Iowa State Extension, we've had smoke seasons over the last several years, given the extensive drought across the West Coast and then the Canadian wildfire smoke that filters into the upper Midwest. We do see a decrease in the amount of incoming solar radiation, but Extension has also shown that once you have that canopy out of corn and soybeans, the smoke actually is a great diffuser. It diffuses that solar radiation a lot better, so you get a basically more coverage across the canopy and more efficient photosynthesis. Now, of course, we're emerging corn and soybeans right now, so we're not really seeing any impacts on the agricultural side, but where you can see impacts, if the smoke does get thick enough, you can tamp down that forecasted temperature by a degree or two or three. But if it starts to mix down into the lower atmosphere, you can get smoggy conditions, and that can impact air quality. And we are seeing some semblance of mixing down of that smoke.
Yeah. There are several states, and you can go to the weather.gov webpage and look at their map, and you'll see some gray states. Those are states where they have alerted for air quality, and most of that is the smoke coming out of the Canada, right? Another question that we had were: are the Canadian wildfires expected to continue? Will we see ongoing smoke throughout the spring and summer? So what I've read, and I would say yes, wildfires will continue. We even haven't really hit the U.S.'s wildfire season yet, but you could see by the maps that Justin showed a little earlier that there's not a lot of red on those. A little bit in some places, but not a lot, especially in the West where we get to smoke and such. So it's a tough call to say whether it's going to happen or not. Now, the West is pretty wet in terms of the higher elevation snowpack. So sometimes we see, now it can, a lot of people in the West will say, well, it'll burn no matter what. But what we tend to see is a lot of growth in these wet years. And then the following year, with all that growth and undercover, we tend to see a more explosive, if you will, fire season. So also what I've read about the Canadian wildfires is there are a number of them that are totally out of control. So whether nature puts them out or not is really the question. And what the airflow is going to do. The airflow can vary quite a bit. So we'll see how that goes. Yeah, airnow.gov is one good place to go. Oh boy, now we started a lot of questions by talking about smoke. I've got a couple more here. Then we'll finish up the well, maybe that's all I had for the smoke. I might get back to that in just a minute. What is the Red River of the North current flooding currently? I believe it's not. There is no snow to melt up there anymore. Generally, they get their biggest floods April, May, when there is a lot of snow melt and there's rain on top of that, which causes a lot of problems. This year, I think they avoided the worst. They had some flooding, but that peak is past, so to speak. Prevent planting, Justin, and this may be a guess on your part. If Brad Rippey wants to say something, feel free. Will prevented planting be widespread in North Dakota and other northern states this year? And I think, again, this goes back to the immense snowpack that they had and late start they had. I haven't heard anything about that, but you guys in the more of the ag side might have.
My powers end at the Iowa-Minnesota line, so hopefully Brad's on, or we can get the answer to that to the questioner after the call.
I have Brad here. Let's see if he's actually listening, and he might say something, or he might not. Oh, he's self-muted, so maybe he's doing something else. Brad, feel free to say something if you want, or type something in there if you care to do it that way. Moving on. Somebody noted that the calculated soil moisture maps seem more spot on than the large blue colored map that you were using, and every one of those maps has flaws. No way that any of those soil moisture maps are perfect. A lot of reasons for that. Justin, do you want to say anything?
Yeah, so a variety of different methods that go into whether it's a land surface model modeling soil moisture, or if it's a remote sensed tool like NASA Sport. That's why we show a conglomeration of those maps to give us an idea if we're moving in a certain direction, so a consensus of information. But things like snowpack, the depth of the frost level, temperatures, moisture, all those impact what we see in those products. So it's a difficult tool to get a gospel truth on, and that's why we use so many different types.
Yeah, we like it to get a lot of opinions on that and then sort of mesh them together, at least in our minds, to figure out what's going on. They're probably not right for your backyard. I'll just say that. They may be more right regionally. You did show a map with a line on it showing that it was warm to one side and cool to the other side. And I think that was your April map or your last 30 days. And the question was, is that because of snowpack? And I did write back on that one saying snow was part of it for the northern reaches of that map. But really, it was simply air mass, cold air moved to the Midwest and glancing blow to the plains a couple of times and kept us, or we warmed up a lot faster than they did to our Midwest. So that's kind of the reason. And really, there wasn't a lot of when you look at the average over the month, there really wasn't. We weren't really that cold or that hot, but as Justin said, we had some really hot days. And then we had some really cold days. So when you do that and average it all out, it comes out to kind of normal. It doesn't tell the whole story, in other words. The extremes. You showed the map with the extreme heat and some of the cold events there. And the question was, is this indicative of a change in climate and all that business? And yes and no. So over a long period of time, if we see a lot more heat records happening than cool records, which we have, by the way. Yes, that is indicative of climate changing. Is this particular one that unusual? No, we set records every year on both sides of the spectrum, but there is a tendency to set more high temperature records than we do low temperature records anymore. Red River,
especially those high minimum temperature records as well.
Good point. Okay, I got a couple more here, or at least comments. Could we see a correlation? Could we discuss the correlation of El Nino with summer weather? Should we expect more? Should we expect more precipitation in the north central region? And go ahead, Justin.
That's a great question. So do we have another hour?
Ah,
My contact information is on, I'll flip to that slide. If you want to send me an email, I can point you to a specific website that can show you for your particular location. We call them super climate divisions. But we have, with analog years in which we've seen El Nino, La Nina, or ENSO neutral for a given season, you can click on this map and it will give you a box plot, which will tell you what the behavior is likely to be if you look at all those analog years since 1950. So if we look at Iowa, and I were to click on that map, if we looked at El Nino and ENSO neutral conditions during June, July, and August, typically slightly cooler and not as dry as that La Nina phase. And you see that across much of the region, but you do have, again, pockets where you don't see the similar behavior. And again, this ties back into the small scale nature of the weather patterns that we have, again, the mesoscale flow, and then trying to tie that to that teleconnection to El Nino. The storm track sets up a specific way during the winter time, and we get large scale behavior. It's a different beast as we get into summertime.
yeah. So summertime is more random, in other words, more chaotic almost,
Yes,
and harder,
yes.
much harder to predict. There are tendencies. So I would say there's a tendency to be less for less extremes. And
Yeah, the variability is tamped down.
Yep. So will that hold this summer? We'll see. First of all, we got to see when El Nino actually takes effect, if you will, and starts changing weather patterns. It hasn't yet. I'm gonna move on a little bit. Not a weather question. Oh yeah. So someone asked, but why the wildfires are so out of control this year in Canada or whatever? It's because it's dry, and I don't know about their management up there. I don't know how they do things in Canada, but they over the last, well, as far as I've known, there are big fires that do happen in Canada, and we're often impacted by that, by the smoke, so to speak. But I don't know. I can't really speak to their management practices.
And I think looking at where the fires are occurring, it's very isolated parts of Canada. So
yeah. A lot of out of controlness out there.
Right.
Yep. And then I guess the last question, I thought we did this one, but it has Canada wildfire smoke damaged corn and soybeans so far?
No.
Okay. Oh, and Brad did type in relatively small prevent planting acreage. Should be mostly limited to eastern North Dakota, western Minnesota, and northeast corner of South Dakota. So not a lot of prevent planting, if any. And I think that's all we have, unless there's someone else. Let's see. Nope, that's it for questions, I think. If I didn't answer anything, feel free to write to either me or Justin, and we'll work it out with you. But I do want to say thanks again to Justin, and thank you all for hanging in there. I know this was a little long. I apologize for that, but we enjoy doing these for you. We'll see you in June, whatever it was, 15th, I think it was.
15th.
Yeah,
15th.
And Aaron, the great Aaron Wilson from Ohio will give us his 2 cents on what's going on. So thanks again, and we will talk to you all later. And thank you, Justin.
Thanks, Doug.